Hello, everyone.
Good morning, Professor.
Good morning. Hello, Cameron.
Yes, Professor.
Have you found your telephone number?
Yes, I have.
Why didn't
I can call you after class.
Okay.
Thank you.
Hello, Dr. Professor Madwali.
Yes, sir. I'm going to start now our talk. And we have an assignment, homework 4. And it is about vending machine. Would you please open it and start reading?
Hello?
Yes, sir.
Sorry, I was just trying to test my microphone.
How is it working? I can hear you well.
Okay, it got fixed.
Okay, great.
All right.
Now, would you please look at this vending machine and
Yes.
tell me how many inputs are there?
5.
5. And those are coins, 5, 10, 25, clock, and reset. How many outputs?
4.
Yes, because we have return. We can return 25, 10, 5. And of course, we need to get the soft drink you are buying. Okay, so those are my inputs and outputs. Hello, Paige.
Hello, Professor.
Have you read this? The assignment?
Yes, just now. I'm just looking it over.
Okay, take your time. When you are done, please let me know.
Would you make it bigger on the screen, please? Or fill the screen with it or something?
But you have it. You have it. This is the assignment homework 4. Get it on your on screen.
I tried to, it wouldn't let me download. I think so many people were on it or something.
You have to download it in order to view it. I don't think it'll allow you to just view it in the on Canvas. You have to download it.
I know that. I said it. It wouldn't let me download it.
Oh, okay.
All right, I'm good. I just looked it over.
Okay. You are aware of the inputs and outputs?
Yes. I think so. We'll see.
Okay. Okay. How much is the Coke? Do you have the price for the Coke?
Each beverage costs 25 cents.
25 cents. Okay. So when you input coins, it will be sensed and it will be known to the state machine how much money you paid. And if you are paying the exact quantity, you are going to get your soft drink. But if you pay more, you will get a return. Paige, according to your great experience, would this be mealy or more machine? You are all
Is
thinking?
that, oh,
Yes, go ahead.
is it a mealy?
Why?
I just feel like it's a mealy, Professor.
No. You wrote down in your own handwriting the difference
Right.
between mealy and more.
Okay.
Read whatever you written.
It's a more because the output depends on. Wait. No, it's a mealy because the output depends on input and the state it's in.
Excellent.
Thank you.
Because the coin return, it depends on the input. How much did I pay? If I paid extra, I will get the return. If I don't pay extra, and I'll get the vending, the Coke only. That's it. Excellent. So that is excellent choice. Hello, Jose.
Yes,
Is it clear to you?
yes,
Okay, Chad,
Yes, Professor.
is it clear to you?
It is clear, yes.
Okay. I'll let you think about this. So we have our assignments. That is lab 2B, it should be uploaded, and this homework. Homework, this is 4. Now we are going to start our new topic.
Wait, Professor, can I ask you a question on that homework 4 real quick?
Okay. Yes,
So it says it doesn't want a counter to be used to count up for each coin you add in, right?
I'm not counting. Why
So-
do I
so you-
count?
Because it says you're not allowed to implement a counter to count the amount of money that you have put in. to the machine.
Because I have here the coin sensor. The coin sensor, it tells you if you have 25 or 10 or 5.
Okay, but do I need to make a state for each one of those that gets put in? So I'd have to make a state for, say, 20, for if I put in 10 cents, I have to then have 3 states that come off that say
No,
put in
those are
25.
input, not states. Those are inputs, not states.
Could you utilize an adder instead of a counter?
You can add adder, yes, no problem. Yes, you can
But
do
you just
that.
can't keep track of the money value, is what
Yep.
is what you're trying to say.
Yes, yes. Adder, not a counter.
Okay, okay. Thank you very much.
Any other questions? Do you want more time to think about it now? Is there anyone who needs more time to think about this one? If you're happy, I'll be happy. No problem. Now I go to,
Wait,
yes,
it says try to optimize your design to use a few states as possible.
okay.
How? Never mind, I'll have to think about it some more. It seems like there'd be a natural number of states, so.
When you do the design, you are gonna decide on how many states do you have. Okay. Week 5, we have 2 homeworks and 1 lab. Those are the topics that will be covered in this lecture. Generic, generate, debouncing, clock, domain. VHDL generic. We are using parameters, and this is a very, very powerful capability of VHDL. And with this, I can adjust the bus width and register sizes. That means the number of D flip-flop. Bus width and register size, this is the number of D flip-flop. Let's see how we may use generic. In the entity, I am going to say bits. This is a parameter, and it is going to be integer, and the default value for it is going to be 8. Within the entity, this is where I declare a generic. This generic, I can use it anywhere afterwards. For example, here I am declaring my counter. It is a standard logic. Where I speak about 8 bits, so I am from 7 to 0. 7, it is my integer or number of bits minus 1. If for this problem I want to change the number of bits to 16, I just do it here once. Now I go to my counter and up, down, adding or subtracting. This is the same one we used before. The only difference is I used here the generic bits. Bits as a generic. And I believe you can do that in no time in your counter program. And for test bench, again, it is going to be declared. And if I want to change it, I can change it at any time. And this will override the 8 that was declared before. This is 8-bit and 16-bit. All what I do is just change one number. I can have more than one generic. For example, bits, we know it, and the terminal count. My terminal count is I am counting those 8-bit number up to what? For example, 255. So I am using the two generics, especially now the terminal counter. This is the difference. If I reach the terminal count, then I will go to 0. Here, please look at this statement. Counter, if counter equals what? I'm converting the standard logic vector, terminal count, and bits. I have 8 bits, and the terminal count of these 8 bits is 255. This is what's happening. Counter, convert standard logic vector, TC, and bits. TC is 255 and 8 bits. This command will fill the 8 bits by the terminal count, which is 11111. This is my condition. If counter equals 11111, 8 ones, that is my terminal count. And that is how it may be used. Now we go to another important statement. It is called generic. In this generate,
Wait, Professor, I had a question on the last part.
okay. Yes. Go ahead. Hello?
Of generic integer, or is it, hello?
Yes, sir. I'm hearing you.
Okay, okay. Is the only type of generic an integer, or are there also other things you use, like I know in other programming languages they have like float or one of those
Yes,
other
yes, can be
types.
anything. Can be anything.
Okay, so it doesn't just have to be an integer, they have other ones you can add in
Yes,
there?
it can
Okay.
be float or double, whatever you want.
Okay, thank
Thank you. Hmm. Now we go to the generate command. We are using here 8 shift registers. Those are my input output. This is the component that I have. And here, the port map. And here you can see the generate statement. In this generate statement, it starts with G1 colon, and I have here a for loop. For loop that will start from 1 to 7. From 1 to 7. Generate what? This port map. I am repeating it several times. How many times? 7. What about the first one? The first one, it is in here, where I have connect 0. The first signal, connect 0, is here. Then I will have Q as connect N. That is 1, 2, 3, 4, 5, 6 until I reach 7. This is a shift register. That means I have 8 bits. I am feeding the first bit to my first D flip-flop. D in is going here, and this clock, and when shift is high, that is enabled. Now I am gonna get output to be connect 0. Then I am having the D input will be the next connect. As we have seen it before, we have seen several D flip-flops. This is the first one, and its output will go to the next, output to the next, and so on. And this is my final output. This is coming out of 7, number 7. So my first D in, it is going to D0, and the output of D0 is going to D1, D2, D3, until I reach D7. In the D flip-flop, the shift register that we made, we repeated that, we retyped that 8 times, but here I am using this generate statement to take the output of one stage and feed it to the next one. Would you please open your old shift register assignment? the assignment you sent. Shift register assignment. Have you got it, Chad? Have you found it?
Would it be homework 1?
Yes,
Okay, then yes, I got it.
you got it.
Yes.
Now read it and compare it to this one.
So Professor, if I'm understanding this correctly,
Yes.
in the previous shift register, you had to create a process with the clock and the if statement declarations and everything like that. But here your generate is kind of your process statement.
Where is your D flip-flop? Can you see this is a component? Correct?
Right. So you list a component as a D flip-flop and you create
No,
a port
no,
map.
you have another file called D flip-flop, DFF. You have another file. There is another file called DFF. And this DFF, it is the one that is using the clock.
Oh, so it's built into the library.
Yes.
Okay. So it already knows that there's going to be a clock.
Here, this is main file. What is doing? Connecting those. But the data is fed to the D flip-flop according to the clock. Reset is over there. So this file by itself, it will not work. It needs the component.
Oh, I see. And we previously didn't have that component. So you have to add
Yes,
this now.
we have it. Yes.
Oh, okay, okay. So let's say you had this exact program, but you changed your bits integer to, I don't know, 16.
Yes.
Would it do the exact same thing?
Excellent. It will do the same thing. If I put here bits 16, automatically the generate will generate bits minus 1. But in the other old program, you have to repeat it 16 times. Can you
Right,
see
for
how?
literally, yes, for each process.
Yeah,
Oh, that's very nice then.
yes, yes, it is. Cameron,
Yes, Professor.
is it clear?
Yes, it's clear to me.
Yeah. Hello, Paige.
Hello.
Is it
It-
clear? Is this clear?
Yes, I'm starting to get it.
Okay, can you see now the difference between this one and the old one?
Yes.
Okay. I'll let you now type this program. I need this program running. Okay. You have the old one. Now you make a new subfolder for this one. And of course, you need to copy the file, the D flip-flop file from the old program to this one to be able to run it. And type it and try it as it is, 8-bit shift register. And run it and compare the running of this program to the other one.
I have a question.
Yes,
So like on starting on line 40 or line 49, what does clock to clock mean and EN to shift?
this clock.
Yeah,
This
like on line 51, he goes clock assigns to clock, and I don't understand why he does that.
Because I used the same variable name in the main program here, and I used it in the D flip-flop. In this port is a copy of the entity of the D flip-flop. And I need to connect the wires. The wire of clock here. How is it connected to the D flip-flop? This is what is done in here and here. Enable. What is it connected to?
Scott,
In the D flip-flop, it is called enable, but here I am calling it shift.
he already had it. He's
That is why they are different.
We didn't know if he was headed out or not.
But clock, it happened to be the same.
Oh, no, he went up to HR.
Okay, sounds good. Yeah, so he's up that way. Okay.
Sorry about that. There was a conversation going on in the background.
Okay. Clear?
I think so. Thank you.
This is enabled in the D flip-flop.
I have a quick question.
Here it
Where,
is called, just let me finish. This is
Okay.
called here shift. I need to assign enable and shift together. In the D flip-flop, we have a clock and have here a variable of the same name, clock. I need to assign them. So it happened that those two are the same. Now your question?
how exactly do we put the DFF folder into this folder? Do we have to put it in a specific subfolder or just drop it in?
No, just drop it in. How is it located in the other program you have? Have you found it in the other folder?
Yeah, I have my DFF
And
folder.
it was dropped right in there.
Okay, so I can just drop it in. Okay,
Yeah.
thank you.
Thank you. We are going to have this until the end of the class. If you have any question, you may share the screen and discuss whatever you have.
I have a 4-bit shift register, but did we have an 8-bit shift register too?
Hello, hello. Any questions?
Yes, Professor, what did you mean earlier by dropping in the earlier VHDL file? Don't we have to make a new one for this?
Yes, you are going to make this program. Just a moment.
Right, but you said like to copy in the one that we did before, like on the homework?
No,
Oh, okay.
I
Okay,
didn't
that was-
say that. I said this one will need this component, DFF. And this DFF, you can take it from the other program. Only DFF. Do you know the component DFF? We have it before.
Yes, the
And we
D++
called
one?
it. Yes. We use two files, main file and DFF file. The main file used to call this DFF. Can you see the two files or not in your old program?
I started a new program, so I have to open up the old program to see what the DFF file was.
No, I
Okay.
don't. I don't see it in my old program.
Your old program didn't use this component? This component, does it exist in your old program? Yes or no?
Yes, it does with all those ports. It does.
If it exists, so there is an associated file with it in the same folder. This command is to instantiate this file. Have you found it?
And when you say that folder, do you mean within the IEEE library or within?
No,
our-
no, within the folder where you have your program. When you start your program, don't you say folder? Don't you specify a folder? The project, when you start a project from scratch, don't you specify a folder?
Yes, I do, because you obviously have to save it somewhere.
And that is where you put the main program and any component.
Okay, let me check the folder then.
For compiling this program, did anyone have to put an end at like line 35, 36? I'm getting an error at the begin on line 38.
Me too, I'm getting the same error.
The component, do you have it? Have you compiled it first? You need to compile the component. It is going to call the component here and it's not going to find it. You are following the same steps you used before.
So how do you combine the components of the DFF?
How did you do it in the previous program?
I didn't.
No, you must have. Do you have the word component in the old program? Component. Do you have the word component written in the old program?
No.
I also don't, and mine was running as well.
Yes, that's exactly what our,
This is the DFF. And this is the program you had.
I had that one, but then I couldn't get my test bench to work, so you just told me
I
the,
didn't say anything about test bench.
oh, sorry, I saw you
I am
sharing that
saying
test
I am
bench
have
there.
here a DFF with enable.
I have that one.
Here is this the one. It's using port.
yeah, I think in all of our shift registers, what we would do is just create port entities. And then in the process, when we would begin, after the architecture, you would basically just cite those port inputs and then what they would be doing with the logic statements or the if-else statements.
I'm trying to find where we set it. I look it up and this will be our first topic on Friday. Okay. We are running out of time. Thank you all.
Thank
And
you,
see you
Professor.
Friday. Thank you.
Thank you, Professor. Have a nice day.
You too.
You really have a good day, sir.
Thank you. Bye-bye.
Bye-bye.